All right, folks, today we're going to be talking about volume. This is lesson 70 in your book. Now, if you think about volume, some of you might be thinking, well, your hair has volume, right? Um, Ladies, at least, are thinking about that. So, volume is how much space something takes up. Okay. So we could talk about volume in water. We measure cups of water in the United States. We could say how much volume is in a pool. But we can also say, like, how much volume does your hair have? How much space does your hair take up? Or how much volume does Trixie take up? Okay. Thinking about how much space is being used. Okay. So we're going to be looking specifically with boxes and cubes today to think about volume. So I hope you've already read this in your book, so none of this should be extremely new. But I want to give you fair warning that my drawings are pretty spectacularly bad because it is almost dinner time and I want to go eat. So you're just going to have to use your imagination a little bit on these. Okay, so example 1 says the rectangular prism is constructed of unit cubes. Its volume is how many cubes? Okay, so before we do that, we need to remember what a cube is. And a cube is a three-dimensional object where all sides are the same length. Okay, so think of a square on all sides. Okay, so all the sides are the same length. So it's asking me on this question if I had this rectangular prism, which means think like a box. Okay, if I put in cubes, how many cubes could I use to fill it? So I need to count my cubes for this essentially, and I say, well, I have 3 cubes this way, right? 1, 2, 3. And then I have 4 cubes that way, right? So then I have 3 cubes this way. And I'm going to multiply these. Okay, what I'm essentially saying, I'm pulling my picture apart and saying, well, on the base, I have 3 rows of 4 cubes. So I have 3 times 4. So on that bottom row, if I cut this cube in slices, okay, and this was 1 slice, I would say that this bottom, hello, oh no, this bottom part would be 12 cubes. Okay, I can't see the 12 cubes, but I can guess that there are 12 cubes. Okay, so then I multiply those 12 cubes by this 3, because I'm saying, well, I have 3 layers, 1, 2, 3, of 12 cubes. So what I'm really doing is I'm multiplying the length times the width times the height. Now, the book does not tell you that, but that's Miss Ballard telling you for a future reference. And that's going to give me volume. Okay, so I said I had 3 here, I had 4 here, and I have 3 here. And when I multiply that, I'm going to say that that gives me 9 times 4, 36 cubes total. Now, cubes, as we said, are pretty exciting because all of the sides are the same length. What this enables us to do is use a new measurement for volume. In this case, cubic centimeters or cubic meters, but you could use cubic feet, you could use cubic yards, cubic inches. And what this is remember how we did our length times width times height, okay? And we multiplied the base times the number of rows, okay? When I multiply it, I'm multiplying centimeters 1 time, 2 times, 3 times. Okay, what that means, if I have a cube that has all the same sides of 1, and they're in centimeters, I'm going to end up with, well, 1 times 1 times 1, which is 1 centimeters, but I have centimeters 1 times, 2 times, 3 times, so it's cubed. And that's how I get cubic centimeters. And I put a little 3. So remember, area has a little 2, okay? Because I'm just finding the area within one spot, but the cubic centimeters is 3D. Same thing with cubic meters. I'm multiplying length times width times height. So if I have a cubic meter, I get 1 meter cubed because I have 3 meters. Okay, that's just something to keep in the back of your mind that the book talks about. All right, number 2, example 2. Find the number of 1 centimeter. Okay, so I'm trying to figure out how many of these little perfect cubes, okay, that are 1 centimeter on each side, I could fit into this box. Okay. Now, you might be wondering, why do I care about this? Well, this is something you really should be caring about now because almost everything is being sent to your house in boxes. So think about this as this is an Amazon truck and it's trying to figure out how they can pack the boxes so everything fits. Okay, so this is actually really important right now, thinking about volume and shipping things. Okay, so for this example, I'm looking at my base and my width. I can think of this as my length times my width. I'm going to start there. So I'm like saying I have 5 little cubes on this part, right? And they're in rows of 4. Okay. So really my bottom row, if I were to cut open this super cool box, would look like that. Okay, so I could say the bottom is 5 times 4, which would give me 20 cubes. But I need to worry about this 3 centimeters here, right? 3 centimeters means that there is really 3 rows of this that way. Okay, so really I have this 20 3 times. So I can think about this as my length times my width times my height. Here's my length, here's my width, here's my height. And I can plug in here, and that's going to give me 5 times 4 times 3. Okay, this is my original 20. That's at the bottom of my my base. Okay, and I multiply it 3 times because it's like saying I have 3 rows of that with the 3 centimeters. So I get 60. I'm not finished though because I have to keep track of my units, and I have centimeters 1 times, 2 times, 3 times. That means I'm going to have centimeters cubed. And whenever you use volume, you're almost always going to be cubed. I can't think of a single time you wouldn't be cubed. Okay, so area would be squared, volume 3D, 3 after my unit, 3 cubed. Okay, all right. Number 3, what is the volume of the cube? Dimensions are in inches. Okay, so what they want you to do again is think about this as having a base, which is your 2 fours, and rows. Okay, or think of it as length times width times height. Well, my base is 4 by 4, so it's like saying, and this is not to scale by any means here, people. Okay, I have 4 cubes that way, and I have 4 cubes that way. So my base would look like this. Okay, that's this 4 and that 4. So my base would be 16. But I still need to have 4 rows of that base of cubes. 1, 2, 3, 4. So think of this as 16 here, 16 here, 16 here, 16 here. So I would multiply 16 times 4. Okay? Or you can think of it as length times width times height, which is way easier. Length is 4, width is 4, my height is 4. Here's my base, my 16, and there's my 4 rows. 16 times 4 is going to give me 64 cubes. And then the dimensions in the book, it says they're in inches, okay? So 64 inches cubed. Need to have that little 3 there to show me it's the volume. All right, last one, example 4. This is kind of like when it's find the area of like the really strange shapes. Think of this as find the volume with the strange shape. All right. Remember your formula that I taught you? That's not in the book. That'll make life easier. Length times width times height. And the most important thing is to figure out, well, where can I divide my shape to do my volume? And I'm going to divide my shape here. Okay. And that will help me do my volume. And I'm going to add my first part and my second part together and find the volume for each section. So my first section is 8 times 4 as my base. Here's my 8 and my 4. And I find my height is 4. So here's my length times width times height. Or base times rows. And that's going to give me 32 times 4. Which is going to give me 128. And I'm multiplying by centimeters 3 times, centimeters cubed. And then I'm going to find my volume for that section. Hello. Okay. So I know that this part right here is 8. And I know that the base right here is going to be 4 because it's 4 up here. And let's see, I already did my height. And then I have another 4 down here. Okay, so I did a little wacky on that one. But I do have a length, a width, and a height. So my length would be 4, my width would be 4, and my height would be... No, Erica, you're doing it wrong. Okay, hang on. Let's see. Back. All right, ignore the last section. Okay. So I'm still going to use this section, right? This is 4. This is 4. This is 4. Okay. But I can't use the 8, right? Because I already used part of the 8 down here. Oh, no. Yeah, so I used part of the 8 down here. So this is 4, right? So I'm done with that 4. So that means that this part is 4, even though it's drawn strangely. Okay, when you guys draw your shapes, you draw them strange too. So that's something to keep track of. It's not always going to look to scale. So really, it's 4 times 4 times 4, because I've already used 4 for this 8 down here, right? So 4 times 4 is my base. That's here. Times 4 is the height, so it's 16 times 4. And my height is, my volume would be 64 centimeters cubed. Now I have the volume for both sections, so I add it up, and I get 192 centimeters cubed. Okay, so what's the takeaway from this? Okay, when you do volume, you want to do length times width, this is your base, times the height of your cubes. You're going to multiply 3 things, and you're always going to end up with an answer that is cubed. Has a little 3 at the end of it. All right, go to your... Okay, just so you know, when you do your practice set, let's see. Practice set, skip letter D. We can't do it. Okay, so just go ahead and skip. Okay, so next for the practice set. Okay, so remember, when I'm finding volume, the easiest way to think about it is the length times the width, which is essentially the base, times the height. Okay, make sure that you are counting the right number of rows, because I miscounted, and that's why my box looks really wonky. So the length of this is 6, and then I have 3 rows over here, cubes, and I have 4 rows upwards. So my base is 6 times 3. Okay, that's this part right here. It's like saying I have 6 cubes and they're in 3 rows. So 6 times 3 is my length times my width. And my height, my number of rows, it's this part, is 4. 6 times 3 is 18 times 4. 8 times 4 is 32. 1 times 4 is 4, plus 7, or 3 is 7. And I need to make sure I have a unit. In this case, they just say 72 unit cubes. Okay, when they say unit cubes, all they're saying is a cube that has 1, 1, 1, like that. Okay, and whatever unit they're wanting. They don't tell us the unit, so we're not going to worry about it. Okay, that's letter A. Letter B. Find the number of 1 centimeter cubes that can be placed inside a box with dimensions as illustrated. Okay, so remembering my equation is length times width times height. Okay, my length is 10. It's like saying I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 little cubes here, okay? And then I would have 10 more there, okay? So length times width, and then my height is this part. It's like saying I have 10 rows, for lack of a better way to do it, of those cubes. So my volume is going to be 1,000. I can count my zeros. Centimeters cubed. Okay, make sure you have the little 3 because it's 3D. All right, letter C. What is the volume of this rectangular prism and the dimensions are in feet? Well, remember length times width times height. Okay, so the length is 10 cubes across times 4. So that's giving me 40, essentially. And then my height would be 6 cubes, which would give me, 10 times 4. Sorry, that's a 4. 40 times 6, which gives me 240. But I'm not finished because I have to have my units, and it tells me it's in feet, and I have a cubed 3 because it's 3D. All right, you didn't have to do letter D because there's no way we're measuring the classroom, but you should know letter E. Okay, this is the big takeaway. Volume equals length times width times height, and that will always give you your volume. Remember, volume always has little 3 at the end of your unit.